All right, so we've got this block here, and we have this inclined plane. It's actually a 3, 4, 5 triangle. So the horizontal force, or the horizontal length is 4, and the vertical length is 3. And I just want to establish a couple things right now. I want to establish that the sine of theta for this is 0.6, and the cosine of theta is 0.8. And here's why. We're going to be setting up an equation here. And we want to pull this block up at constant speed. So let's get a free body diagram going. So we're going to have the weight. We're going to have the normal force like this. And you know what? I don't quite like how I've drawn this. I'm going to draw, the normal force goes up like this. Sorry about that. Now I'm going to have this pulling force here that I'll call the force of pulling. And let's be clear, I'm going to have mg sine theta here. I'm going to have mg cos theta here. And since I'm pulling up, the friction force is going to go downwards. So let's see if we can actually set up some equations up here. So I'm going to have Fp minus mg sine theta minus the force of friction, which is going to be mu times the normal force, which is mu mg cosine theta. I want you to explain to me how I'm getting this as the force of friction. Like, how is all this giving me the force of friction? I want you to figure that out by balancing the forces for the normal. Now, once we actually get this solved, the pulling force is going to end up being, well, since the mass is 5, that means the weight is going to be 5 times 10, which is 50 newtons. So I'm going to get 50 times 0.6. And sorry, these should be added to, and this is going to balance out to 0. These all balance out to 0. I should have said that earlier. And now that means the pulling force is going to be the weight times the sine of theta. Plus, I'm going to add to this 0.3. That's 0.3 times 50 times 0.8. So when I actually work that out, that's going to be 30 plus 12, which ends up being 42 newtons worth of force. And then for number 7, in the absence of air friction, an object dropped near the surface of Earth, constant acceleration. What does this actually mean? This is false. This is false. This is false. This would be true if it were the second derivative, but it's not. And that leaves us with choice A. Now, problem 8. Ooh, great question. So we've got this ball thrown in the air, and there's no air resistance. Let's be really clear on this. The whole time that the ball is traveling, after I've thrown it, the acceleration is downwards due to gravity, and the net force is downwards due to its weight. That's pretty much it. We're going to take a look at problem 10 in the next video.